Welcome back to the lecture on radioactivity. This is part 2. Part 2. In part 1, we were on properties of alpha particles. This will take us to number 2 property. Number 2 property is that alpha particles are massive. That is, alpha particles are heavy. And because they are heavy, they are slightly deflected by either an electric field or a magnetic field. So let's look at it. Alpha particles are massive. In other words, heavy. Hence, they are slightly deflected by either an electric field or a magnetic field. Number 3, the direction of deflection shows that alpha particles are positively charged. The direction of deflection shows that alpha particles are positively charged. Number 4 property, alpha particles are stopped by thin sheets of paper, or we can say carbon paper. Okay, carbon paper, thin sheets of paper. This shows that they have the lowest penetrating power of all the 3 types of radiation. Number 5 property, alpha particles cause a great deal of ionization in gases or air. What that means is that when alpha particles collide with air molecules, it knocks off the electrons in the atoms of these molecules, thereby converting these atoms to ions. Hence, that process is referred to as ionization. So alpha particles cause a great deal of ionization in gases or air. Of all the 3 types of radiation, alpha particles have the highest ionizing power. And lastly, alpha particles cause a substance like zinc sulfide to fluoresce, to glow. In other words, when alpha particles come in contact with zinc sulfide absorbs the energy and begins to glow. This will take us to properties of beta particles. Let's look at the nature. What do we see? And we say this is a beta particle. The nature of alpha particle is helium nucleus, like we said before. So what then is the nature of beta particles? Beta particles are fast moving electrons. So it means that beta particles are electrons. So when a radioactive element decays and emits a beta particle, what do you see? And you say this is a beta particle. Let's look at the disintegration. Remember, we said this process is actually the disintegration process, or what we call the decay process. So when it decays, when the radioactive element decays, it produces a beta particle. So this is how a beta particle is represented, and the daughter element. So how do we resolve this? Don't forget, this place is A, this is Z. We have ascertained what A is and what Z is. So it gives you this, which is our beta particle. So how do you get the mass number, nuclear number, and the proton number of the daughter element? You just do A minus 0, that gives you A. And then Z minus, that's plus 1, that will give you Z plus 1. Don't forget minus is plus. If we back up a bit to alpha particle, you will see that when it emits and produces an alpha particle, to get the daughter element, we just do A minus 4. That's it. And then we do Z minus 2. That's it. We go to property number 2. Beta particles are light. Unlike alpha particles that are heavy, beta particles are light. And because they are light, they are strongly deflected by either an electric field or a magnetic field. Hence, they are strongly deflected by either an electric field or a magnetic field. Number 3, the direction of deflection shows that beta particles are negatively charged, which confirms that they are fast moving electrons because electrons are negatively charged. Number 4, beta particles are stopped by thin sheets of aluminium, which shows that they have a greater penetrating power than alpha particles. Number 5 property, beta particles cause ionization in air, but not as much as alpha particle. We have already discussed or explained that ionization is when the particles collide with the electrons in the atom of the molecules of air and knocks these electrons off such that the atoms become ions, and the process is referred to as ionization. So beta particles cause ionization in air, but not as much as alpha particle. And lastly, beta particles can cause zinc sulfide to glow, but the glow is weaker when compared to alpha particles. In other words, the particle, that is the zinc sulfide, absorbs the radiation beta particle and then begins to glow, but the glow is weaker when compared to alpha particles. This will take us to properties of gamma rays. What's the nature of gamma rays? What's the nature? Let's see. We have ascertained that the nature of alpha particle is helium nucleus. The nature of beta particles are fast moving electrons. They are electrons. Then what then is the nature of gamma rays? Gamma rays are electromagnetic radiation with very short wavelength. They are electromagnetic radiation with very short wavelength. So let's see the disintegration or decay. You have the radioactive element with the nuclear number and the atomic number. So when it disintegrates to produce a gamma ray, it is represented this way. So this is how you represent a gamma ray. And then you have the daughter element. To get the atomic number and the mass number of the daughter element, you will do Z minus 0 to get Z, and you will do A minus 0 to get A. Property number 2. Gamma rays are not particles. Hence, they are not deflected by either an electric or a magnetic field. That is, they are neutral. Gamma rays are not charged particles. And because they are not charged particles, they are not attracted to the electric field or magnetic field. They are not deflected. Let's look at property number 3. Gamma rays are stopped by thick lead blocks. That is, they have the greatest penetrating power of all the 3 types of radiation. So let's back up a bit. Alpha particles can be stopped by thin sheets of paper. Beta particles can be stopped by aluminium sheets, thin sheets of aluminium, and gamma rays can be stopped by thick lead blocks. We continue this lecture in part 3.